Okay, hopefully you've had a minute to think about this question. And in answering it, I want you to consider the situation when you're running one lap around a track. So here we go. We're going to start one lap around. Here you go. We start and finish at the same place. Question is, I want to know the distance that you ran. Well, that's a pretty easy question to answer if you know that one lap around the track is 400 meters. If I can write. Distance around the track, 400 meters. The next question is, we're asking about distance and displacement. What is your displacement when you run one lap around the track? Well, if displacement is the straight line distance from the beginning of a trip to the end of a trip. Think about that for a second. What's your displacement? Your displacement, since you start and end at the same place, the straight line distance from the beginning to end would actually be 0 meters, which is kind of funny to consider that you might run all the way around the track, you'd be panting and completely out of breath by the time you get to the end, and you would actually have a displacement of 0. Kind of depressing. But this is physics, it's not the real world. Yes, you ran 400 meters and that wasn't a waste of time, but we would say that your displacement is 0. I use that example to take you to this example. Let's consider this. A hiker travels 8 miles east and then 2 miles north. What distance has he traveled and what is his displacement? Okay, I've switched to your notes. This is the problem that I just gave you in the PowerPoint. A hiker travels 8 miles east and then 2 miles north. I want to know what distance he traveled and what's his displacement. All right, the first thing I want to do when we are given problems like this, and it'll happen in the future again, is we need to draw a picture. It's always a good idea to draw a picture with every problem you get. But you should know, and if you don't, I'll draw it here. You should know what a compass looks like. North, there's east, there's south, and west. So I'm just going to draw the picture of what this guy does. First he goes 8 miles to the east, and then he goes 2 miles to the north. I want you to notice one thing, that I drew the picture to scale. 8 miles. In other words, if this is how long 8 miles is, I can't draw 2 miles this long. That doesn't make any sense. You need to draw it to scale so that it makes some sense. You don't need to use a ruler or anything, but just consider your scale. Alright, what distance has he traveled? Remember, distance, we're not concerned about direction. I just want to know the actual path that his feet have traveled. With distance, all we have to do is add up the distance of the 2 legs of the trip, 8 and 2. So for distance, all I would simply do is add the 2 legs of the trip, 8, then 2, that gives me a distance of 10 miles. Remember, distance doesn't take direction into account, so that would be my answer for the distance that he's traveled. And now for the question about displacement. Displacement is a little more interesting. Remember that we said displacement, and it's up here. Displacement is the straight line distance between 2 objects and the direction from one to another. Straight line distance between 2 objects. In other words, you could say in this type of question, it's the straight line distance from the beginning of the trip to the end of the trip. Straight line distance. So literally, I will draw a straight line from the beginning to the end, and I want to know the length of that line. All right. We'll talk about the exact direction a little bit later, but for now, we'll just simply look at the distance of it. Notice that we've just drawn a triangle, and you might realize that this is also a right angle, and you might know a few things from geometry about right triangles. I want to know the length of this side. You might remember that the length of that side is given by the Pythagorean Theorem, which is a squared plus b squared equals c squared. In case you don't remember, on a right triangle, this is side A, this is side B, those are your 2 legs, and your hypotenuse, or the side that's opposite the right angle, is always side C. A squared plus B squared equals C squared. That's what we need to do to find the length of this side, or the straight line distance from the beginning of his trip to the end of his trip. So I'll simply plug in my numbers. A squared is 8, or A is 8, B is 2, and I want to get C squared. What I do is I typically solve for C using algebra without ever doing arithmetic first, but you can do whatever you want to do. I want C, so all I really need to do is take the square root of both of these sides. So literally in your calculator you can punch in the square root of 8 squared plus. So I'll punch in the square root of 8 squared plus 2 squared right now for you. I'll show you how to do that in case you don't remember. To get square root or a radical, that's second, and then x squared button gives me the square root, and then 8 squared plus 2 squared. Close the parentheses, hit enter, and I get 8.25. I'll leave it at 8.25. Okay, so my C now equals 8.25 meters. But remember, or miles. Remember that displacement takes into account magnitude and direction. So this is not 8.25 miles. We're going to indicate the direction right now just by saying northwest. It's on some northwesterly track. Okay, he's moving on a northwest path going in this general direction. Later on we'll use degrees and sine, cosine, and tangent to talk about the direction, but for right now that's all I'm concerned about is that right there. Let me show you a different way to do this algebra just to show that you get the same thing. You should know that 8 squared is 64 and 2 squared is 4, and that equals C squared. 64 and 4 is 68, and then again you can just take the square root of 68. I'll do that now. Second, x squared, it gives me square root of 68, and there you go, 8.25. Gives you the same thing. So his distance he traveled is 10 miles. 8 plus 2. Displacement in his straight line distance from the beginning to the end, that's 8.25 miles to the northwest. Again, displacement is a triangulation thing. We do that using Pythagorean Theorem. Alright, let's move to the next problem. And to start out, I wrote on here, this says change. I know you can't read my handwriting. I want you to change, instead of west, I want you to write north. Alright. So a car goes 65 kilometers to the east and then 45 kilometers to the north. Once again, let's draw our picture. 65 to the east. 45 is shorter, so I'm not going to make my line quite as long. 45, and I'll put my units on here as well. That's very useful. 45 kilometers to the north. All right. We want to know the distance. We want to know the displacement, just like in the previous problem. Okay. Distance, again, we're not concerned about direction. That's an easy question to answer because all we have to do is add up the 2 legs of the trip, or however many legs we've had. Actually, we'll see that in this one. So I'm going to do 65 plus 45, and even though this one is in kilometers here, I'm not really concerned about changing the units at this point. I did tell you we always use meters in this class, but right now, since we're not using any actual equations, I'll go ahead and leave it in kilometers. 65 kilometers plus 45 kilometers. Forgive me, I'm not very good at math. I do have to use a calculator. 45 plus 65 is 110 kilometers. So that's the distance. 110 kilometers. Now for the displacement, once again, you'll notice displacement, straight line distance from the beginning to the end. That is a triangle again, and once again, we will use the Pythagorean Theorem. A squared plus B squared equals C squared. In this case, A is 45, B is 65. By the way, it doesn't matter if you switch these. It doesn't matter if this is A and B or this is A and B. It comes out with the same thing. Equals C squared. So again, I'll just take the square root of all of this. Second, x squared gives me the radical. 45 squared plus 65 squared. Close parentheses. And there we go. 79. I'll call that 79 even. C equals 79, and our units are kilometers. We'll just stay in kilometers for this one. And remember, displacement, we must indicate direction, and you might have noticed that he's moving again in a northeasterly direction. Oh, I'm so sorry. I said northwest on this one up here before, and that was completely incorrect. Hopefully you've caught me. Northeast is what we need up here on this problem. Northeasterly direction. My fault. It's not always going to be northeast, by the way. These two happen to be. It'll just depend on what directions you are given. All right. So there's distance and displacement. Now let's move to this one that's next. I want you to read this, pause the video, and try to work it out on your own. Okay. Hopefully you've had some time. I'll go through this with you. Once again, draw a picture. It's very, very important that you draw a picture, even on the simple problems. This one happens to not be quite so simple. So first we start out going 5 blocks to the north, and I'll draw that as an arrow going up to the north. Then we turn and go 7 blocks to the east. Remember, I'm keeping my relative distances correct, so I'm going to make a line that's just a little bit longer than the 5 line to indicate 7. So here's my 5 blocks, here's my 7 blocks. And then I turn and go 8 blocks to the south. That's going to go down, so I want that to be just a little bit longer than the 7. And label that 8. 3 blocks west. Okay, so now I'm going to turn and go back west, that's to the left, and make that 3. And then 3 blocks to the north would be something like this. Okay, and that's all we got. That's where we end up. First question, what distance has he walked? I just want to know the path his feet followed, and I don't care about the direction. 5, 7, 8, 3, and 3. All I have to do is add those up. 5 plus 7 plus 8 plus 3 plus 3 gives me a distance of 26 blocks. So the distance, I'll go ahead and write this out. 5 plus 7 plus 8 plus 3 plus 3 equals 26 blocks. That's the distance he walked, but I have no idea what direction he walked. That comes in when we calculate displacement. Displacement, once again, is the straight line distance from the beginning of the trip to the end of the trip. In this case, you might notice that if you use geometry, all these are right angles, which means that if we look at this distance here and this distance here, notice that 5 and 3 add to 8, which is on the other side. So I know because of that that this must be a right angle. This angle must be a right angle as well. Okay. In other words, the displacement, this is where we started and this is where we ended. Our displacement direction will be in this direction, due east. Due east. So I know that much. As far as the magnitude of the displacement, we don't have to do a triangle on this one because you should be able to tell just by looking at this picture how long this line is. All right, since all of these are right angles, we can look at the top. This is 7 blocks. And by the way, we're assuming that one block is the same distance as the next block, which I know is a big assumption, but we're just going to go ahead and make it for now. If this is 7 blocks down here and this is 3, you know that's what is left of this must be 4. 7 minus 3 equals 4. So this has to be 4 blocks. So I know from that calculation that my displacement, I might go ahead and as my work, I might say 7 minus 3 equals 4 blocks. And displacement takes into account direction, 4 blocks east. 4 blocks east. Notice also, we went through this long path to get to here. Displacement is much less than the distance. Okay, so the answer to this question a long time ago is distance and displacement always going to be the same? The answer is no, because if we've gone different directions, most of the time it's going to be different. This displacement is much less than this distance. And it doesn't matter. I don't care if we started here and we did something like this. We snake all around like this. This would be a very, very long distance. But as long as we end up in the same place, the displacement is the same. Once again, displacement is the straight line distance from the beginning to the end. I do not care what happened in the middle. Do not care what happened in the middle. Same thing with the example of the track. You run around the track. Your distance is 400 meters. Your displacement is 0. Displacement is 0. Displacement is 0. And again, it's the same if you start at the beginning and you run around the track and you go over here and get a drink of water and then you go here and talk to your friend and do all this stuff. As long as you start and end in the same place, you still have the same 0 displacement.